All right, good afternoon, Principles of Engineering. Welcome back. We are working on activity 3.1.5, variables and functions, and that's going to be within our MyPLCW right here. So I have pulled up the PowerPoint. We're going to go over that briefly, and then we'll get to work on actually using variables and functions. So let's start from the beginning here. Let me move this so that there's no glare. That is a little better. So to start, a variable is stored in a robot memory, and this could be something like a whole number, a decimal number, a word, and those variables names use the same rules for naming a motor or sensor, so including capitalization, spelling, and availability. And then the variables can improve our readability of our program or expand it to do more things. So for example, we start with integer cleared equals 0, all right? And that's just to, if we have an encoder, maybe we have the optical shaft encoder, and we want it to start and have a new 0 cleared before we start the program, we can do that. So for example, variable creation. So at the beginning, before we even get into writing the program, you need to actually put in before the task main. So here, if you see on my computer, I have task main. Before the task main, you would define your integer. So example, I would be integer speed. And so once you define speed, then, or once we identify that speed is an integer, then we need to define what speed is. So it can't be anything that's already reserved, so you can't use words that the computer already recognizes, like while, if, else, left motor, things like that. It needs to be some other terminology that's not typically picked up. So you have different types of data that can be used. So integers can be any positive or negative whole number, whereas a floating point number is one that has a decimal. All right, and then Boolean is true or false. So it'll see is the statement true or is it false. If it's false, it'll do this. If it's true, it'll do that. All right, and then character and string we're not going to get into because we don't even have the ability to do them here. So, but that would be perhaps later. If we get a computer integrated manufacturing class, we might be able to get into stuff like that. So, like I said, we talked about over here. And once again, I'm showing you my computer monitor. I'm gonna put this back a little bit. There we go. That's better. Now I can see better. So we've identified that speed is an integer. I'm gonna go ahead and do a semicolon here and enter. And then I would identify that speed equals 0. All right, and semicolon. So right now I'm saying speed equals 0. And so I'm declaring initializing our typically combined in single statement. That's here. Integer speed. You could do it like this way, integer speed, and then speed equals 0. Or we could combine it all together and just say integer speed equals 0. And get rid of this other one. Boom. All right. So the value of a variable can be referenced by using the variable name and the place of the value. What that means is that instead of having to actually type in a speed, we could type the word speed, because right now our speed equals 0. So left motor would be -1 times 0. Okay, and -1 times 0 would be 0. So the left motor would not spin. And we could put a counter, so we could progressively make the motor get faster every 2 seconds or something like that. Based off the word speed. So in the example above, the motor speed is set when the line is executed, and the motor does not change automatically as the variable changes. Okay. So here we go. So the statement right of the equal sign is evaluated, and the value is assigned to the variable on the left side. So for example, integer speed is the declaration. The assignment is that speed equals 0. Excuse me. And that speed can be changed. So if we say speed equals speed plus 1, all right, now anytime we reach a speed, it's going to add the number 1. So then speed would become 1, and then speed would become 2 if it sees speed again, or things like that. So the left side of the assignment operator has to be the variable name, and then afterwards you would identify what it means. So don't flip-flop this. So the variable goes on the left, or the name of the variable, and then the variable itself goes on the right. So we can use variables to do things like repeat a code 5 times. We can count how many times a button is pressed. We could make it see if a button's ever been pressed. Remember a maximum value, so maybe I move my potentiometer 17 times, it could tell me the highest it saw. And I could even debug a program by remembering which branch of code has been executed. So let's start with something simple. Task description, start and stop a motor 5 times. Instead of writing the same code 5 times, we can use a variable and it will count how many times for us. So here's our simple loop. I'm going to remove this. So while we're going to do integer count equals 0, integer count equals 0, task main, and then I am going to get rid of this for right now. And instead of while 1 equals 1, because that would cause this program to run forever, we're going to say while the count is less than, where's less than sign? There you go. And is less than 5, okay, do this. So let's say start motor, left motor at 50, semicolon, wait 1, stop motor, left motor, and then I would do count equals count plus 1. So let's see how bad I did. We'll see how this works. Compile program. Nope, I don't want to save. Compile program. (3_1_5). All right. We'll see. Wait, I forgot the semicolon after wait. It told me. Here, so now I can compile the program. Let's down to the robot. Okay. I'm going to turn my robot on. Okie dokie. And now I'm going to download the robot. Let's see what happens. Okay, so I have my motor on. I'll move my camera down there in just a second. Let's see here. I need to click start. How long did that run for? I think that ran for 5 seconds. Clear all. Start again. Okay, so that ran for 5 seconds. What I did was say start motor. Let's change this to here. Wait 1 second again. So now it'll start motor. It'll turn the motor on for 1 second, turn it off for a second, and then because what was happening, I told it to stop motor, and since the computer reads things so fast, it didn't register that the motor had stopped. All right, so we're going to give it some time to start stop by adding in that stop command. So let's compile and download. Now let's see what happens. Okay, so if you look at that motor down there, I'll go ahead and click start again. Okay, and so we, instead of having to write a while loop that runs forever, we could actually limit it to only run for a certain amount of time. So for example, later on you might have a project where I tell you the program has to turn itself off after 2 minutes. You could have a count that would then run the program for 120 seconds. All right, so that is just one of the things that you can use a variable for. Let's move on to the next option. So we can count the number of times a user does something. So how many times did a user press a button or remote, and using a variable to remember how many times. All right, in this case, here's our code. I'm going to go ahead and type that in. So we have integer, and this they are identifying as in press, so the number of presses equals 0. That's the integer, or the variable, and then the integer is here. So integer in presses equals 0, semicolon, task main, while, and we're going to do sensor value, sensor value, and then the limit switch equals, parenthesis, equals 0, close parenthesis. Okay, while that is 0, look at this code. In this case, our code, if, parenthesis, sensor value, and then bump switch, parenthesis equals 1, parenthesis, and then we're going to open up with a curly brace, and in presses equals in presses plus 1. So anytime it comes back around and checks for in presses, it's going to add 1. Right? So as much time as I'm pressing the bump switch, it will count how many times I'm pressing the bump switch. Okay? And then in presses plus 1, semicolon, until release. So that's going to be, until release is the command for once you let go of the bump switch, otherwise it won't. You could also probably write it that bump switch equals 0 until bump equals 0, because that would mean the same thing. Release bump switch, parentheses, semicolon, and then we're going to say wait half a second, and we're just giving it just enough time. Oh wait, 0.05 seconds. All right, and semicolon, and then we have a closed bracket and a closed bracket. So I'm gonna go ahead and do that. Compile the program. Code generation not performed. Why not? So I have an extra curly brace, or I have not enough curly braces. So this curly brace opens, this opens, this opens, this one closes, this one closes. That means I have not enough curly braces. I need to have one close. So now I can compile and download the robot. All right. The battery is low, so 1 second. This is why I keep several charged. Yeah, go plug that in, and all right, so now that we have another battery here, all right, compile, and we'll download the robot. All right, so now I'm going to say start, and it's going to go that way for a long time. So I'm going to touch my bump switch. Okay, so I'm pressing it as many times as I want, and then once I press the limit switch, all right, it should tally that up. So I'm going to press the limit switch now. Okay, now how do I figure that? I might need, nope, come back. Before a limit switch was pressed. Global variables. Alright, so then if I look at my global variables down here, alright, and if you can't see that, you would need to go to Robot, and you would go to Debugger window, and you would make sure the global variables is chosen. But I have variable defined as in presses, so I touched it 91 times, apparently. Let's clear that. Okay. Clear all. Let's try this again. So I'm going to start. I'm going to do it again. And every time it's counting for 0.05. So because I'm not releasing it fast enough, it's actually counting each press. And so if I hold this, I'm just holding down one. And it's counting as many times. So now I have 55. All right, I'm going to go and stop this program, and I'm going to record a second video. So make sure if you have any questions, ask each other, and I will go ahead and help out here in the future if I can. Otherwise, please talk to your fellow classmates or the substitute. Thanks, have a great day.